video is about being able to determine the difference between an Sn1, an E1, an E2, or an E1. Which one of those four reactions are going to happen, and there's really four types of substrates those could happen on. Just a methyl with a leaving group, primary carbon, secondary, or tertiary carbon with a leaving group. So I'm not going to go over the details right now of how each one of these reactions occur. I'm assuming you know that. I'm just going to try to distinguish between which one of these four happen. And this is just going to be a basic chart. It should work most of the time. It should get you through figuring out which one of the four is going to occur, and then you can write the correct product. Especially if you want to determine if it's a substitution or elimination. You should be able to figure those sort of things out. Okay, let's start with a methyl. The methyl is usually the easiest. Will an Sn2 happen with a methyl? Yes, definitely can happen with a methyl. I'll even put an exclamation point there. Yes. Can an Sn1 happen? No, with an exclamation point. And the reason I'm going to put the big no, the no of the exclamation, is we can't have a methyl that is a carbocation. Meaning because the first step is losing the leaving group. So that's not going to happen. Now let's say for the E2. The E2, I'm going to put a huge, monstrous, big no, and a big no for the E1. Why? Because there's not enough carbons on there to make a double bond. There's only one carbon on a methyl, so it's not even physically possible for those to happen. So we're really looking at Sn2 for the methyl. So that's an easy one. Let's move over to the primary now. Can Sn2 happen on primary? Definitely, just like the methyl, you could definitely have an Sn2 that occurs. Can you have an Sn1? No. It would be really unusual to have an Sn1 here, because that means you'd have to have a primary carbocation, and that's just unlikely. So for the same reason, no for the E1, again, because it's very unlikely to have a primary carbocation. Okay? Now, let's look at the E2. Yes, this is possible. I tend to prefer the Sn2 here, because the substitution in one step would be easier with the Sn2. The E2 could happen if the base is strong and bulky. So like an RO minus with an R group. Remember, R stands for carbons and hydrogens. If the R is huge, and it's like an RO minus for the base, to remove that hydrogen and then form the double bond, that could be possible. So let's say a T-butoxide could be possible there. If it's not sterically hindered, if it's not huge, it's going to go Sn2 for the primary. And that's usually what you'd guess for primaries. Secondaries are painful. And here's why. Yes, first of all, well, let me just reveal the truth here. It could be any one of the four of these. And that's why the secondaries tend to be the toughest. Any one of the four. So let me help you kind of distinguish between these. For the Sn2, the top one, you need a good nucleophile, and one that's not too bulky, and it shouldn't be that strong. So an example would be, say, I minus. Okay? If it's too strong of a base, it could go elimination. If it's too, so if it's too strong, you'd suspect maybe an elimination. So let me maybe write that down. So with a strong base, like a RO minus, OH minus might do it. And you'd really want to confirm with your instructor here what they think is a big enough base to form the E2 reaction, and strong enough. Hydroxide's kind of on the line because it's usually the smallest strong base that people put there. I've usually seen the OHs go here for a yes for an E2, if that's the attacking group. But again, that's something you can double check with your instructor. Okay, now for the Sn1 and the E1, you usually have something like a solvolysis. So you have a weak base for either Sn1 or the E1. A weak base, that would be something like, let's say you had ROH with RO minus, and RO is a weak base. Okay, so you really have just ROH. So you see like methanol under the arrow or by the arrow, or added to a group it wants to attack. Okay, the one that has the leaving group. Same down here. You'll have some sort of ROH. And by the way, those could be water too. Some sort of maybe alcohol or water looking structure. Those that tend to go Sn1 or E1. And the reason is they're not a strong enough nucleophile to come in and attack and say remove a hydrogen in the case of the E2. And they're just not strong enough nucleophiles. One comment I want to make, if you have high temperature, this is high temperature here. High temperature, you're going to prefer the E1 over the Sn1. So low temperature thus will prefer the Sn1 over the E1. Okay, so temperature can play a role. If you see a temperature thing on there, you'll want to remember that E1 prefers the high temperature. Okay, so it could be any one of those. Again, just to summarize, if you got a strong base, maybe if it's bulky, I'm going to think in E2. If you have something that's kind of a weaker base but a good nucleophile, then I'm thinking Sn2. If I see something with an OH group on it, then I'm thinking an Sn1 or an E1. Alright, so let's move on to the tertiary. Sn2, I'm going to put a big no here. No for the Sn2 because the tertiary is just too large for an Sn2 attack. So if you have a tertiary group, it's hard to get in there to do that backside attack for the Sn2 that it requires. Yes, though, for the Sn1 and the E1. Sn1 and the E1. And for the same reason as before. So if you have an ROH or water attacking in either this case or this case, it's going to be one of those. And that's what I call solvolysis. You can have, and so it's usually some weak base and that, whatever that weak base is, not one of your typical strong bases. Okay, now, you're saying, well, what if I had a strong base? Then that's this one. Yes, for the E2, if you have a strong base. And again, that would be the RO minus and the OH minus. That, one of those would definitely cause the E2. So again, strong bulky bases, we're thinking E2. Good nucleophiles in general, but not necessarily as strong bases, we're usually taking Sn2. And if we have a weak base with its alcohol present, then we're thinking one of these two with the E1 preferred over high temperatures. Also, one more thing, you can say that Sn2s typically prefer aprotic solvents, or the reverse would be true. Sn1s prefer protic solvents. And you can see this is a protic solvent. This is even the E1 prefers the protic solvent. This prefers the opposite, so not protic solvents, or not things that will give away protons. Alright, so that's your basic summary. You'll want to double check with your instructor to see, you can show your instructor this table during, say, office hours or something and see if that makes, that works for what they talked about in class. But this should get you through discerning between these different examples. And you'll see other videos coming up that will be examples where we can use this table to determine what kind of product we're actually going to have.